Hello everyone. Today we are going to discuss about building integrated photovoltaic. So this is the application of photovoltaic technology in construction field or construction sectors. So as we look at this picture, we can clearly see that how the solar photovoltaic are embedded into the construction structure. Actually, the meaning of building integrated photovoltaic technology is that the not just installing the solar panel on top of the rooftop or the exterior to the construction of the building. It is the matter of fact that the solar panels are embedded into the structure. Actually, it become a part of the building material, part of the required construction material, let's say roof or facade or whatever things. Okay, so let's look at this slowly. The building integrated photovoltaic refer to the solar technology that are seamlessly incorporated into building structure to generate electricity. That's an important key. The embedded incorporated into the building structure. It should be into the building structure. Rather than adding conventional solar panels on top of the existing structure, building integrated photovoltaic is embedded directly into the architectural elements such as roof, facade, and windows, making the solar technology both functional and aesthetic. So it is it having advantage of keeping the solar material as a functional, not the passive element. It become an active element. I mean, in the sense that it is part of the building material. Okay, this integration not only generates renewable energy but also as part of the building envelope, which help reduce the need for traditional building material and can offer insulation benefits. So the key here is that by adopting the building integrated photovoltaic technology, we can reduce the requirement of material. We can save material, construction material. We can save cost because we are going to use the solar panels as a construction material for the, let's say, roof tiles or uh, any other part of the material. So that's the key here. So you can understand that now. This is also I'm introducing the technology application of the photovoltaic technology in different field. Now we are talking about application of photovoltaic technology in building construction sector. So these keywords, as I said in earlier videos, it is very important. Then only you can read the article, what research is going on in your area. Like if you are from construction sector, you are engineer in construction, or you are a civil engineer, then you can little bit learn about this technology. Then it is good for you to introduce a product, or you can do a startup, or you can embed this technology into your existing building or new building. So these are the things you can get the benefit out of this. Okay, so let's look at one by one. Photovoltaic roof. This is the traditional roof. Like we have a traditional roof here, and what we are doing, we are placing the solar panels as an additional additional material to generate electricity. But look at here these solar panels become a part of the roof. It is not additional, it is the part of the roof. It is a part of the roof. So solar cells are embedded within the durable glass tiles to mimic standard roof tile. Okay, it become a standard roof tiles. Okay, so this is the next version of technology, because why we have to waste money to buy the solar panels and put it in the on top of the roof as an additional material, rather than if we are sure we are going to have a solar photovoltaic panels, then we can embed those panel into the roof. There are limitations, there are problem challenges. We will look at that last on the last slides. That's obviously we will, any technology have some problem issues, practical difficulties. That's fine. But this is a technology, this is idea. If you are going to uh, run this panel for 25 years or 30 years, rather than keeping in additional material, we can embed it into the house construction material. Okay, that's the idea here. Okay, okay, let's look at PV facades. So these are PV cells integrated into the building exterior wall can generate power while providing an insulation barrier. Again, the facade based building uh, photovoltaic system can be used to high-rise building, mainly for high-rise building. You might see these kind of big walls or build places where it is well exposed to the sunlight. Okay, so we can use the solar photovoltaic material, make it beautiful or aesthetic. It's a aesthetic design. By looking at this itself, you can see that usually in a roadside building they put some drawing or design or something. Here it is because of the solar panels. It looks pretty nice, pretty aesthetic or beautiful. So this is can be a future model for when you building a aesthetic walls or any barriers. You can have this kind of photovoltaic material. Okay. Next is a PV window. So the windows incorporate transparent or semi-transparent solar cell into the glass panels. Okay, the important thing is even incorporate small smart technology to adjust tilted based on the sunlight exposure. Okay, you can open the window little by little based on the requirement sunlight exposure. Okay, I mean it's automatically we can have a automatic opening and closing. It's a control by like building automation. You might heard building automation system mean the windows can automatically open and close. How it's happened, we will learn in future videos like in electronic based system or smart homes. So those with together with the idea, if we put the solar panels as a roof sorry window material, so the control system of building control system can incorporate this idea of generating electricity. So the tilt angle is taking care of, the tilt angle taking care by these building automation system, because if you keep in a particular angle, let's say now is in this much angle, so from here you can see like maybe about 30 degree. At this 30-degree angle we get the good sun solar radiation, so we'll keep it at 30 degree. And then after sun moves, we might need to go to the 60 degree, 70 degree or something like. Okay, so those kind of things we can do by a PV window. So I just introducing is a very simple concept. I'm not telling any too much technical things. Just introducing, because when we introduce, when we hear a lot of things, we can do as a product, and we can do a startup companies, or we can make it as a product, and we can get the benefit out of even from your own house. Okay, so here it's very simple. Okay, maybe other things are quite difficult for you as as a simple person, or I mean the household owner. But let's say you want to put some shading. So rather than putting the shading in buying the metal sheet or metal um, uh, uh, the metal sheets, or uh, we can put the solar panels. So usually if you want the shading, we need to buy some material, construction material. So rather than buying that, we can put the solar panels as a shading. It's a directly you can do in your house. Okay, but I am saying like other technologies like other things are quite difficult. As a household owner, you can't do it because you already have a house. So even if you are building a new house, you have to consult with the construction engineer, or the person who is a designer in designing your building. So they have to accept, they have to agree this idea of integrating solar panels as a roof or wall. So it quite a decision making. I mean, it take little bit of time to accept everyone to do this kind of integration. But what I'm saying is this kind of simple integration. These are the simple, very simple integration. Like you need a shading, rather than putting the metal board or metal sheet, we can simply put the solar panels as a direct shading. So it gives a shading as well as it generates electricity. So these are the simple, very simple ideas we can slowly adopt. By adopting these simple ideas, we can encourage renewable energy power generation, reducing the cost, total cost. So the efficiency is increased. In efficiency means that the space related efficiency. We are not generating electricity by capturing the space. Okay, we need this shading for this space, so we can do without much effort. Okay, so what are the advantage of building integrated photovoltaic? So first thing, energy efficiency. As I said, like energy efficiency mean is not about panel efficiency. Efficiency in terms of how much space or land area we are using, because we are not using land area because we already embedding the solar panels into the building construction. The construction, anyway, the construction is going to consume some space in the land, so we are going to sit on that particular construction. So it means efficiency improve. So we are moving towards the net zero emission target. So because of this, we are moving. The goal can be achieved easily, because if it is a embedded system into construction material. I mean, if it is become a construction material, everyone will start to adopt this solar panel. So it become, we quickly can able to reach the net zero energy goals. Okay. Second one, aesthetic appeal. So as I saw in one of the picture, so we can create the aesthetic appearance of the walls or even rooftop by keeping the solar panel. So building architecture become a beautiful one, and people will start to like or love to accept this approach of building integrated photovoltaics. Okay, then the cost saving, as we discussed earlier, we are instead of buying two material, one is for roof, again solar panels material, we are now going to buy only one material, that is going to act as a roof as well as it going to generate electricity. Same thing for the wall, we are not going to put the wall then put the solar panel. So we are going to keep one material, that is a solar panel material, that can work as a wall as well as generating electricity. So likewise, so the cost is reduced. Next is environmental impact. It reduced the carbon footprint. As we know very well, the solar power generation reduce the carbon footprint, minimize the fossil fuel based electricity generation. So this really help to protect the environment, cool down the environment, and a lot of benefits. We are helping the environment to be a green environment. Okay. So the idea is this. Idea is very simple, but when implementing, we might see quite challenges. So idea here is building integrated photovoltaic. Photovoltaic technology is available. Okay, we are going to integrate into building as a part of the building, not the additional things, as a part of the building. So as I said, like earlier, these kind of projects or startups or anything has to be consulted with a civil engineer, the design structural engineer. So he has to tell, because when we put the roof, we know particular weight only a roof can carry. Okay, particular material should be in particular weight. We cannot load too much weight on the roof. So structural engineer knows the limitations and problems and all sort of things. And the roof has to be particular tilt angle, in the tilt angle in terms of water flow and different other reasons for the house. So the solar panels has its own reason to keep particular tilt angle, because the solar radiation has to fall perpendicular to the panel. So we as a solar PV engineers, we have a particular requirement, and civil engineers or structural engineers, they have the particular requirement of how to build a house or building. So these two requirement has to be matched or compromise or come to the common ground. It's a negotiation. So come to the common ground without affecting the customer requirement, customer comfort, or the quality of the building. In that case, we are going to have a common goal of keeping the photovoltaic material as an integrated material into the building. So this is a quite a good project, but it's quite challenging as well, as we learned last week about the agri-voltaic technology, agriculture, how we can use agricultural land for the solar PV. Okay, I mean coexist, both production is going to be exist. In similar way here, we need an expert opinion, like expert from the civil engineers. They need to advise solar PV engineers or power engineers like me, how we can integrate this into the building. But in future we will get more this kind of things into the practical world, because these are quite a good idea. Okay, so when the material technology improved, so they are doing a lot of, right, a lot of research is going on how to improve the building materials. One side, how to improve the solar panels material, I mean improve efficiency, make it less weight, make it more affordable. There are a lot of material. So in future, in 5 to 10 years, they will come up with the best material to suitable for this kind of integration. Okay, let's look at the challenges. The last slide, always we have challenges. Every technology has its own challenge, own limitations, own negative thinking. In other words, we can say some kind of negative thinking. Okay, high initial cost, because upfront cost is system higher than the traditional construction material. Because combining both technology, it's new idea. So it's new mean the structural engineer designing things and actual buying the material, it is expensive at the moment. As I said, when we technology improve, the material aspects improve, it will slowly go down. Okay, the next one is efficiency and design constraint. Okay, now the is solar PVs are built into structure. It may face design limitation regarding orientation. As I said, like, okay, we as a solar PV engineers, we need a particular orientation to keep the solar radiation falling into 90-degree. But actual roof uh, may have different orientation required because of the structure. So this complication may reduce efficiency. Okay, because we had to accept one per, I mean usually we accept whatever the structural engineer says, because structure is very important. Okay, we can't say like I need only 30-degree tilt angle, so make it the roof 30-degree tilt angle, because it is not logical to influence the angle of the slope in the civil engineering we say slope of the roof. We cannot influence that by solar PV radiation, whatever requirement, I mean our requirement. Okay, then last one, durability and maintenance. Here is a big problem comes, because we say the solar panels can last for 25 to 30 years, maybe maximum 30 years. But the house, we are building the house for to keep 100 years. Okay, usually people say the houses can withstand 100 years. So this two is a big contradiction, because we need 100 years to keep the house, but the material can last for only 30 years, solar PV material at the moment. So we had to come up with a material which can last more than 30 years, up to 100 years. This is a big challenge. As I said, researchers are going on. We can come up with the idea. I think we come to the end. I need to finish before 20 minutes. So thank you very much. Please continue watch this channel. Please subscribe and give your support. Thank you.